Washington State University. Go Cougs!
Survey and questionnaire methods. These are probably going to be things that many of you are going to be using in terms of your research. So self-report, you give a questionnaire to an individual and you ask them to, a common one might be, let's say I want to know something about a person's memory. So I could give a questionnaire to an individual that asks them to say, how well do you remember people's names? How well do you remember what you need when you go into a room? And one of the things that a person could do when they're filling out a questionnaire is they're going to have to think back retrospectively on kind of their history of remembering those things, right? And then check off how well they think they do. Now, I could try to get a little bit closer by having them at the end of the day think back and say, did you forget anyone's name today? Did you forget where you left anything today? And so I could have them do that daily, and then there wouldn't be so much retrospective remembering. I could even come into the moment, and we're doing a lot of this now, called ecological momentary assessment. And so I can say, right now, tell me, are you fatigued? Are you, feeling depressed? And I can get information in the moment about how a person is feeling. The other thing that we can try to do to get information about a person is to use this think out loud process. So as a person is completing a task, we could ask them to describe what they're doing as they're doing the task so that we can try to understand a little bit more about kind of a person's thought process. And if any of you are helping out or have helped out with the night out task, you would have may have experienced like doing this think out loud. So we can get that information from self-report. And, if you're a healthy older adult, you're probably going to do pretty good with this, right? But what happens if I'm asking someone with memory problems, with more significant mild cognitive impairment or dementia, to tell me how well their memory is? What do you think is going to happen? Am I going to get good data? No, because one, what are they lacking? Yeah, insight or self-awareness, right? If they don't have good memory, they may not be able to think back and give me good information. Or let's say I have a healthy older adult, but they're trying to look good, right? Then they might be biased to answer my questions as if they think they have, better memory. So one of the things that we often do is we try to get informants or people who know the person well to give us information about the person. So we could have an informant, it could be a spouse, it could be a clinician, rate that person's memory abilities. And oftentimes with people with mild cognitive impairment and dementia, we actually find that those relationships that they tell us about their memory are more related to their actual objective memory performance than the person's own self-report. So we can see that when we use these types of measures, we do have to be careful that people, one, have good insight, so can answer our survey measures well. But two, we do have to be cognizant that there can be some biases in how people may answer the questions that could affect our data. Does that make sense to everyone? Okay. This is also a big one that we use in neuropsychology, and that is standardized tests. So this is an example of our trail making test that actually some of the students as part of our Geron Technology class made a digital version of this where we could actually get more controlled data. So here we say, this measures attention, it measures mental flexibility, it measures visual spatial scanning. What you have to do is you have to quickly alternate between numbers and letters in order. So 1A, 2B, 3C, 4D. And we can have a person do this test, And then again, we want to score it to say we think that this is a good measure of mental flexibility, for example. And if we give this test again a week later, then we would want to find pretty similar performance. Now, one of the things that many of our neuropsych tests are subject to is practice effects. So actually, if you do this test and I gave it to you a week later, you're going to be better at this test. Now, if I test an individual with mild cognitive impairment and I say, come back in a year and I'm going to repeat these tests and see if there's been any decline in how you're doing, I have to take into account practice effects, because maybe they look the same, but most people would actually get better because there would have been practice effects from doing the test before. So we think that usually by the time a year goes by, we don't tend to see practice effects, but it's still something that we have to keep in mind if we're doing test-retest data. But these are measures that we can use. And again, it's important to make sure they're reliable and they're valid. Now, this is kind of a whole new area, at least in the neuropsychology, and what we're used to working with is all of this continuous sensor data that we can get now. So we have wearable sensors where we can get lots of information about sleep wake, about activity level. We have, smart home sensors where we're trying to turn that information into telling us about activity recognition. Now, a lot of times what ends up happening with this sensor data is we end up collapsing it down to like, okay, this is an average for a month or, a week of data. But ultimately, what we really want to be able to do is look at those subtle changes that can happen with fluctuations. With activity recognition, this is something that we're trying to validate right now. We have people who are looking at the sensor data and saying, this person is eating, this person is grooming. And we have people that are living out there in smart homes right now, and we're saying, we're recognizing that this is a relaxation episode. This is a eating episode. This is a grooming episode. But we don't really know that, or that data is valid, right? That we're actually capturing, our activity recognition algorithms are actually correct unless we have a camera in the environment, right? And we can match up that, yes, this is what this person is doing now. Now, how many of you would want to live in a smart home that has a camera in it? Anyone? Any takers? You could get some takers, that would be great. No takers though. Okay, so can you think of any ways that we might be able to, in the real world, how could we find out if our activity recognition algorithms are correct? That when our activity recognition algorithms thinks someone is eating, that they're actually eating. Think about some of those methods that we talked about. Okay, so maybe we could have someone keep like a diary like all day and say, this is the time and this is what I'm doing now, right? So they could do that and then we could match it up. So that could be one way that we could do that. We'd have to have a really invested person, right, who would really be willing to keep track of everything that they're doing for us. But that's one way that we could do it. Any other ideas? Declan? Huh?
Like run people through tasks, like while you're observing just one.
Okay, so we could maybe say we'd like you to, in your everyday environment, run through the washing hands task 10 times and like see how they're washing their hands, and then like get a measure of like this is really what it looks like when they're washing their hands because they've done it 10 times. And now we can feel pretty comfortable that this, if we see this in the data, then that might mean they're washing their hands. Of course, they could decide to change the way they're washing their hands too, but okay. Anything else?
Setting up services like areas like fridge or microwave in the dining room.
Okay, so maybe, and that's what we have. We have sensors in there, and we're trying to say that this data we're capturing is really representing, say, grooming. So I'll tell you how we're doing it, but these were also reasonable ways that we had thought about to do it. So basically, the individuals have a tablet, and when our activity recognition algorithm senses, and this happens about 4 times a day, senses a specific activity that they're involved in, it actually will cue them then to come over and look at the tablet, and then they can say whether or not that activity was what they were actually engaging in. So that way we can decide if we think they're engaging in a take medication activity, that yes, we're actually accurate that that is. Now, the reason that that's so important is that those of you who are working on the Digital Memory Notebook project, one of the things that we're going to be having the smart home do is feed information into the Digital Memory Notebook. Now, we don't want it to feed in wrong information and say, you've taken your medication when you haven't taken your medication, right? Or you've, showered or groomed when you haven't done that. And if we're using this data, period, to be able to decide or come up with ways of recognizing changes in activities that might represent slow change or an acute change, such as they had a medical event and they might need some assistance, we need to make sure that we have accurate data coming in, right? That makes sense to everyone? Qualitative method. So we're talking a lot about quantitative number methods, right? Like getting numbers that we can actually do statistics on and that we can work with. But there's a lot of great data that we can get just from open-ended exploration. And sometimes it may be the only way to get data. So last year, and we're finishing up this study right now, we actually had a group of GSER students who watched a video of our older adults or individuals with dementia who were going through our smart home, and when they had trouble completing a task, they actually got an auditory prompt that told them what to do. And we wanted to see how they responded to that. But we didn't feel like we could ask them and get really good insights from them in terms of what it was like. So we had the people just watch and code all their behaviors as they were doing it, so that we could see, were they getting frustrated? Like, what was happening as they were being prompted. The other thing that we've done is we've used interviews and focus groups. So we taught individuals with mild cognitive impairment and their care partners how to use a digital memory notebook. And then we asked them through a focus group afterwards, we kind of talked to them about what they learned during this process, and we developed themes from that. So, 2 themes were, one was like a support theme. So people felt that they no longer felt isolated, they had social support, other people were going through this too. And we also saw more of an empowerment theme. So I'm feeling empowered, I have a game plan, I have tools to help me compensate now for my problems, I understand what's happening a little bit more. So rather than get quantitative information, you can get some sort of themes or understanding of what maybe your intervention or what what sort of question you're trying to answer. That could later lead to some more quantitative data. 2 other techniques just to mention that kind of contrast each other. One is a case study, where you do very, very intensive study on one individual. So for example, those of you who are working on the robot study, once that robot is built, probably we will be doing some very intensive studying with just one participant for a long period of time to try and get as much information as we can on how those interactions are working. Now, the problem is that may not then generalize to the next person, right? There have been people throughout the neuropsych literature, like Phineas Gage, who had the tire iron through his head and then was no longer Gage, had lots of executive disinhibition problems, where we've learned a lot from them, but it could be that because their brain was a little bit different from other brains, that it may not necessarily generalize. Now in HM and Phineas Gage, a lot of things did generalize, but that's one of the things that you have to be concerned about. The other method that's kind of on the other end is a meta-analysis, where you take all these different studies that have looked at very similar things, but maybe in different ways, and you combine that data together, and then you ask questions to see if you can find relationships. And we did some of this work looking at how cognition was related to these performance-based measures and questionnaires that tell us about everyday functioning, to see if we could find some patterns in the data. And we did find some things like informant reports were more related to cognition than self-report, which is what we have seen in the data. So we were able to show, like at a group level, bringing all this data together, where we could find similarities or more global conclusions. And then the last area is computer research. So we can do computer simulations, we can do artificial intelligence. Really, a lot of these computer simulation work are limited by the hardware and the programs that the researchers write. So here's an example of a study I actually did with someone in education, where we were looking at this problem of, I forget the name of the, it's a Piaget task, but basically you give a child these two containers, and then you give them this one big container, and you actually pour the water from this cup into the skinny cup, and then you ask them which one has more water. And of course, they both have the same amount, right? But until a certain age, children will say the one that's taller has more water in it. So there are different models about what cognitive processes might be involved in that. And so what you can do is you can create a model, and then we call it, like, you lesion the model. So you take this part of the model that's learned out of it, and you see if what gets outputted afterwards looks like the type of answer you might get from a child. Okay, so there are some really interesting things that you can do with computer models to also learn about the brain and whether you can model things that you actually see in the real world. All right, so that was like, I mean, there are whole classes on research methodology, so I basically had to like try to expose you to a lot of different methods in one 50-minute session. So I do hope, though, that you did learn something about these different methods that can be used, and that you reflect on the types of methods that you might be using.